moment of inertia rotating in the same sense about their regular axis passing through the center and perpendicular to the plane of a disk with angular velocities omega 1 and omega 2. So they're brought in contact face to face. So like this is a disk and another disk is also brought in contact. So what is happening now? If it is rotating with like this is rotating with omega 1, this is rotating with omega 2. So what's going to happen is that there is the relative velocity is not zero, there is sliding, so therefore friction will act. So now how friction will act? So if suppose omega 1 is greater than omega 2, so in this direction the velocity is more, so therefore friction will act in this direction. And for the below disk, the friction is going to act in this direction. Okay, so this is the point of contact of disk 1 and this is disk 2. Okay, so if suppose omega 1 r and this is omega 2 r, if this is greater, then what is going to happen? This friction is going to act in this direction, and here friction is going to act in this direction. Friction will act in opposite direction. Now since friction is going to act in opposite directions in both the sense, so therefore the torque of friction for first it will be like positive, for second it will be negative. So net torque is going to be 0. So therefore the angular momentum is going to get conserved, because the net torque on the system is 0. Friction becomes an internal force of the system. So therefore I1 omega 1 plus I2 omega 2, which is the angular momentum initially, this will be equal to I1 omega plus I2 omega. So therefore omega becomes I1 omega 1 plus I2 omega 2 divided by I1 plus I2. Now expression for loss in energy during the process. Okay, now the moment of inertia is same, so therefore we have omega 1 plus omega 2 divided by 2. Okay, so therefore the loss of energy is going to be, previously the kinetic energy was half I omega square for 1. So this is the initial kinetic energy minus half into, okay, so of course this is omega 1 square plus half I omega 2 square minus half into I omega 1 plus omega 2 by 2 whole square. Okay, so let us do this. So half I omega square plus omega 1 square plus half I omega 2 square minus initial kinetic energy of both minus half of I omega 1 plus omega 2 by 2 whole square, and this has to be multiplied by 2 because 2 both of them they are having the same omega, so therefore it becomes half I, okay, omega 1 square plus omega 2 square minus 2 omega 1 square plus omega 2 square plus 2 omega 1 omega 2 divided by 4. Okay, so this is gone, this is 2. So therefore this is omega 1 square by 2 plus omega 2 square by 2 and minus of 2 omega 1 omega 2 by 2, which is equal to half I omega 1 minus omega 2 whole square divided by 2. So therefore this will be equal to 1 by 4 I into omega 1 minus omega 2 whole square. So therefore the answer is going to be B. Thank you.